You know, from the movies you stream to the route your map app suggests, AI is pretty much everywhere. But how does it actually work? Well, it might seem like some kind of digital magic, but today we're going to pull back the curtain. Because it turns out that behind most of the AI we use, there's a surprisingly simple and universal recipe.
But before we get to that recipe, we have to talk about the single most important rule in all of AI. You might have heard of it. Garbage in, garbage out. It's a simple idea, right? But the consequences are huge. If you feed an AI system bad, messy, or just plain wrong information, you will get bad, messy, or wrong results back. Every single time. In AI, everything, and I mean everything, starts and ends with the data.
And hey, don't just take my word for it. Check out this quote from AI pioneer Andrew Ng. He says that if a staggering 80% of the work is just getting the data ready, then making sure that data is high quality is the whole ballgame. It's not just a step in the process, it's the most critical, time-consuming, and foundational part of building literally any AI.
Okay, so with that crucial rule locked in our minds, let's get to the blueprint itself. This 5-step recipe we're about to walk through, well, it's the engine behind almost every single machine learning system out there today. Here they are, the big 5. First, you gather the data. Second, you choose a model. Third, you select a loss function. Fourth, you choose an optimizer. And finally, number 5, you evaluate. Now let's break down what each of these actually means.
Let's start with step 1, which we already know is the most important one, the data. If machine learning is our recipe, then data, well, that's our ingredients. And just like in cooking, the quality of your ingredients is going to determine how good your final dish tastes.
So, in this step, what we do is we collect a whole bunch of data, and then we split it into 2 really important piles. The first is the training set. This is what we use to actually teach the algorithm. We let it study the examples and start to see the patterns. The second pile is the testing set, and we keep this hidden away. We'll use that one later on to see if the model actually learned the concepts or if it just, memorized the answers to the test.
So what does quality data even mean? Well, think of it as a checklist. It's got to be accurate, obviously. It needs to be consistent with no weird formatting. It has to be complete, no big missing chunks. It also has to be timely. You can't predict today's stock market with data from 1985. And, of course, it has to be relevant to the problem you're trying to solve. If you miss any of these, you're starting with some pretty sketchy ingredients.
All right, now we get to the heart of the whole process, the core training loop. This is where steps 2, 3, and 4 all come together. If step 1 was gathering our ingredients, this is where the AI actually learns how to cook. It's a non-stop cycle of trying something, tasting it, and tweaking it.
Step 2 is all about choosing your model. Think of this like picking the basic type of recipe you're going for. Are you making something simple, like a salad? That might be a linear model. Or are you trying to build a complex, multi-layered cake? That's more like a deep neural network. The model you pick defines the whole structure and what your AI is capable of.
Next up, step 3, the loss function. Now this is absolutely fascinating. This is basically how the AI tastes its own cooking. The loss function is just a fancy mathematical way to measure how wrong the model's prediction is compared to the right answer. A big loss number means the dish tastes terrible. A really tiny loss number means it's getting really close to perfect.
And that brings us right to step 4, the optimizer. So based on that taste test from the loss function, the optimizer's job is to go back and tweak the recipe. It's like a little robot chef constantly adjusting the internal knobs and dials of the model with one single goal in mind: get that loss number as close to 0 as possible. And this cycle, predict, taste, tweak, it happens thousands, sometimes millions of times.
Now, here's where you can really see how this recipe is universal. Look at this. If we want to predict house prices, we might use a linear model. But if we want to classify images, say cats versus dogs, we'd use a neural network. See? Different models, different loss functions, different optimizers, but the fundamental 5-step framework, it's exactly the same. You just swap out the components for whatever job you're trying to do. Okay, so after all that training, all that tasting and tweaking, it's time for the final exam. Step 5 is where we find out if our AI can actually perform in the real world using data it has never, ever seen before.
This is the crucial step of evaluation. Remember that testing set we hid away back in step 1? Well, now we bring it out. We feed this brand new, totally unseen data to our trained model, and we see how well it does. This is the only way to get a truly honest grade on its performance.
Now, the biggest danger here is something called overfitting.
And I absolutely love the analogy here. Overfitting is when the model has memorized the training recipe perfectly, but it didn't actually learn the principles of cooking. So, the moment you give it a new ingredient, that test data, it completely falls apart. A good model learns to generalize. An overfit model just memorizes.
So, how do we measure this performance? We use specific tools called metrics. For a task like identifying cats in photos, we might use accuracy. What percentage did it get right? But for predicting a house price, we might measure the average dollar amount of its errors. These metrics give us a hard number, a real score for how successful our model actually is.
So that 5-step recipe is the foundation of pretty much all AI today. But what if the recipe could start to teach itself? That's where the next evolution is headed, using something called feedback networks. See, a traditional network just plows forward, from input to output. But a feedback network can take its own output and feed it back into an earlier part of itself. It's a way for the AI to do a kind of self-assessment, to have an internal deliberation before spitting out the final answer. It's almost like it's learning to think about its own thinking.
And this visual just shows the difference perfectly. On the left, the traditional network is a one-way street. Information just flows straight through. But on the right, the feedback network is more like an internal conversation. The output can loop back and influence the earlier steps, which allows for some incredible reflection and refinement.
And this self-correction can happen in a few different ways. It can reflect after the fact, kind of like a food critic tasting the final dish. Or it can do it iteratively, like a chef tasting and adjusting the seasoning while they're still cooking. But the most advanced way is intrinsic reflection, where the ability to self-monitor is baked right into the AI's core design. So, we started with a simple 5-step recipe. But we end here with a system that can not only follow that recipe, but can reflect on it, critique it, and improve it all on its own. And that, of course, leads us to the biggest question of all. If an AI can learn and correct its own recipe, what are the limits to what it can create next?